Hello students, today I welcome you on behalf of RASA International School. Today we will study physics of class ninth. Chapter name is Forces and Laws of Motion. In this chapter, we will discuss today about Newton's first law of motion, mass and what is inertia. So here we start. Here in our last chapter in motion, we have discussed about a body moving along a straight line or along a curved path, changing its position from one position to another position with some speed, velocity, and acceleration. So, there we have discussed about uniform and non uniform motion, and here you are able to see some of the examples on figure number 9.1, where we will study the effect of force on these objects. The first one is the trolley moves along the direction we push it. So it can be seen easily that it is being pushed by the boy in this direction. So the trolley is also moving in that direction in which it is being pushed. Similarly, the drawer is pulled. So it is being pulled in this direction and it is being coming out from the cupboard. Similarly, the hockey stick hits the ball forward. So when it is being striked over here, the ball is moving in the forward direction. So here we are discussing about the impact of force, that is the push or the pull. For many centuries, the problem of motion and its causes had puzzled scientists and philosophers. So a ball on a ground, when give a small hit, it does not move forward or it move for forever. What is true? Here we will discuss about these things where the body at rest will remain at rest and the body in motion will remain in motion until and unless an external force is applied on it. मीन्स कि जो बॉडी रेस्ट में है वो हमेशा रेस्ट में बनी रहेगी और जो बॉडी यूनिफॉर्म मोशन में है वो बॉडी हमेशा यूनिफॉर्म मोशन में बनी रहेगी अपने ही पर्टिकुलर डायरेक्शन में जब तक उस पर बाहर से कोई फोर्स नहीं लगाई जाएगी. सो हियर वी विल डिस्कस दीज थिंग्स in this chapter. So here we start. Now, first of all, we discuss about the impact of force on different things. So the spring expands when the force is applied on the either of the directions. A ball, a spherical ball over here, is being compressed and its shape is changed as the force is being applied by the hands from both the sides on it. So now we in last chapter is studied about the various effects of force, that the force can change the state of rest to a state of motion, the state of motion to the state of rest. It can change the direction of the body, it can change the speed of the body, and it can change the shape or you can say the dimensions of the body. So in our life, everyday life, we observe that some efforts is required to put a stationary object into a motion or to stop a moving object. We ordinarily experience this as a muscular effort and says that we must push or hit or pull on an object to change its state of motion. So that means force is a push or a pull which change the state or direction or the speed or the shape. So here we will discuss about what is that magnitude of force, how we can calculate the magnitude of the force which has been applied to change the state of body. So let's start with balanced and unbalanced forces. Now there are two types of forces. One is balanced force and the other one is unbalanced force. When an object is placed and From both the sides, the same force is applied on it, means 6 Newton from here and 5 Newton from here, and another force is of 1 Newton is applied in the same direction. Now you can say that the sum of the forces on either sides is equal to 6 Newton, and here if we take this direction as negative and this direction as positive, so it is plus 6 Newton on this side and minus 5 minus 1, that is minus 6 Newton on this side. So we can say the resultant force on the object is 0 Newton. Now we can say that here the forces which are acting on the body or the box which is placed is equal to 0 Newton. That means the object is under balance condition. There will be no impact on the body because of these forces applied on it. So an example is being shown over here on where a book is being placed on the table and the two forces are being applied on the either sides in the opposite direction, and due to which the fo- due to which the book will not move. Why? Because these two forces are equal. Suppose these two forces are not equal, then the book will displace in the direction in which the force is greater. Then the condition is said to be unbalanced. So let us consider a situation in which two opposite forces of different magnitude pulls the block. In this case, the block will begin to move in the direction in which the greater force is applied. And in that condition, the book is under a unbalanced condition, means where the forces are unbalanced. Okay. So now we are moving further. Here, two children are pushing the box. But during that push force, a frictional force between the surface and the box is also there. If the force which is applied by these children is not greater than the frictional force, the box will not move. Or if the force is less than or equal to the frictional force, then also the box will not move. So when will the box move? When the force which is being applied by these children is greater than that of the frictional force between the box and the surface, that is on which it is being placed. Okay, so now let us take an example. But we say right now that a body in motion will continue in motion and body at rest will continue in rest. But in our day-to-day life we see that when we stop pedaling, the bicycle begins to get slow and finally it get stopped. So this is again because of the frictional force acting opposite to the direction of motion. In order to keep the bicycle moving, we have to start pedaling again. It thus appears that an object maintains its motion under the continuous application of an unbalanced force. कहने का मतलब ये है कि हम जब बाइसाइकिल को चलाते हैं तो तब तक ही वो बाइसाइकिल चलती है. जैसे ही हम पैडल को स्टॉप करते हैं, वी स्टॉप पैडलिंग, देन इट becomes slow and finally it come to rest. Why? Because of the frictional force between the tires of the bicycle as well as the surface of the ground. So in this way we can say that a body will remain in motion until and unless we apply continuous unbalanced force on it. Okay, it is thus appears that the object maintains its motion under the continuous application of unbalanced force. However, it is quite incorrect. But this thing is not correct. An object moves with uniform velocity when the force, pushing force or the frictional force acting on the object are balanced and there is no external force on it. If an unbalanced force is applied on the object, there will be change either in its speed or in its direction of its motion. So let us correctly understand this with the help of Newton's first law of motion. This law of motion basically have to consider the ideal condition that there is no frictional force and there is no air resistance. Means we are in vacuum. Then Newton's first law say that a body in motion will continue in motion and a body in rest will continue in rest. Or you can say a body in rest will continue remain in rest and a body in motion will continue in motion until and unless an external force is applied on it. Means if the bicycle is moving, it will continuously moving if we stop pedaling also. Why? Because the two conditions are there. There is no air resistance and no frictional force. Okay. So the presence of frictional force, the presence of frictional force, okay, acting opposite to the direction of motion is the cause which stops the bicycle to move when we stop pedaling, or the air resistance, the air present in the atmosphere also opposes the motion. Okay, so that can be feel when we are moving in a car or on a two-wheeler. If we can feel the resistance of the air. Okay, now here we can see that in this case the ball is being dropped from the inclined plane. Okay, it will come back to the same position and again to the same position and again to the same position if we change the angle, and it will continue to move throughout its life. Means whenever for the infinity time it will continue to move if there is no air resistance and friction. This is what about Newton's first law of motion and Galileo's law of inertia. Okay, so here we go. What is inertia? If we play carom board and there are the dice, okay, so what we'll do, we will strike with the striker the carom coins. What the the coins which are the coin which is at the bottom will be moved out with the help of the striker, okay, but the other coins will remain in the same vertical position. Why this happen? Because of the inertia. Now what is inertia? Mass is the measure of inertia. Higher the mass, higher the inertia. Lower the mass, lower the inertia. Means greater the mass, greater the inertia. Lesser the mass, lesser the inertia. So this can be explained with the help of a coin. Okay. And so when we are playing a card, it flicks with the finger. The coin placed over it falls into the tumbler. जब एक ताश के पत्ते के ऊपर हम एक कॉइन रख के उसको ग्लास के ऊपर रखेंगे और उसको हिट करेंगे फिंगर से, तो वो कार्ड जो है वो तो मूव कर जाएगा लेकिन कॉइन जो है वो ग्लास के अंदर गिर जाएगा. क्यों? बिकॉज द कॉइन वांट्स हैव द इनर्शिया ड्यू टू विच इट वांट्स टू मेंटेन इट्स स्टेट ऑफ रेस्ट. कॉइन जो था स्टेट ऑफ रेस्ट में था और हम कार्ड को मोशन में ले आए, लेकिन कॉइन क्या चाहता था? अपनी स्टेट को मेंटेन करना चाहता था. दे आर थ्री टाइप्स ऑफ इनर्शिया. वन इज इनर्शिया ऑफ रेस्ट, second is inertia of motion, and third is inertia of direction. Means a body which is in the state of rest try to maintain its state of rest when the external force is applied on it. A body which is in motion try to maintain its motion when the external force is applied on it, and a body which is moving in a particular direction, if it has been forced on applied on it, it try to maintain its original direction of motion. So that is what about inertia, and mass is the measure of inertia. Okay, now we can understand inertia with the help of example. So suppose a book is placed on a table and you want, or simply when we are in a bus and it is in stationary position or it at rest, when it start moving then we feel that our body try to move backward. The upper part of the body feel a jerk in the backward direction. Why? Because the lower part of the body is in contact with the bus. It comes in motion along with the bus, but the upper part of the body want to maintain the state of rest. This is what inertia of rest. Now, when the bus suddenly applies the brakes, we feel that our body is moving in the forward direction. Though the lower part of the body comes in rest along with the bus, but the upper part of the body wants to maintain the state of motion, so it moves in the forward direction. That is why the seat belts are being provided in four wheelers, and more than that, why? To avoid any mishappening because of the inertia of motion. Then inertia of direction. If you are moving in a particular direction in a car, and if suddenly you take a left turn, you feel that your body is moving in the right, but it is not moving in the right, it is moving in the previous direction in which you are traveling. So that is the inertia of direction. So we will continue in our next video about Newton's second law of motion and Newton's third law of motion. Thank you. For admissions, you can contact on the page which is next to it on the mentioned numbers for class pre-nursery to ninth.